Graphing absolute value by transforming y equals the absolute value of x. So we're just going to be transforming the absolute value. Remember, the absolute value is the V-shaped graph. So remember, let me get this so that you can see it. So remember, the parent function looks like this. I'm going to change a few settings on the graph just so that you can see it all. Okay, so if you look at this, you can see that it starts at the origin, and we call this the vertex. So this vertex starts at the origin, and then it goes up one and over one, and this goes up one and over one this direction. So this is the V-shaped. We've looked at like creating the table and why it does that, because the absolute value of -1 is +1. The absolute value of +1 is also +1. So I want to look at two different graphs. So notice this blue one, hopefully you're not colorblind, is y equals the absolute value of x minus 3. Notice this minus 3 is inside of the absolute value. And then this one, the green one, is x plus 3. So I'm going to show that. So if we look at the parent function, this red one, and then we notice the vertex is now 3 units to the right. Well, if I used 3 as my number and I plugged 3, this number, into that equation, it would be the absolute value of 3 minus 3. Well, if you think about 3 minus 3 is 0, and the absolute value of 0 is just 0. So that's why that one's graphed there. Then if I do the absolute value of -3 plus 3, so now I'm using this green equation, so this equation right here, I'm using -3, I'm just using the vertex, so -3 plus 3 would also be 0, and the absolute value of 0 is 0, so that's why it's graphed like that. So I want you to think about if the number is inside of the absolute value. Since we're talking about transformations, that means, is it shifting? Is it stretching it? Anything like that. So if it's a minus 3 inside of the the absolute value bars, notice it moved 3 to the right. If the 3 is positive, it's moving 3 to the left. So just keep that in mind. So notice we're going to call that H. If you look right here, we're going to call that H, and that's going to do a specific thing to the graph each time. All right, now I'm going to change this -3 to being outside of the absolute value. And then I'm going to move this out of the way. So notice again, the parent function is the red one. So if I am looking at this blue equation and I have the absolute value of x minus 3, notice the vertex is now 3 units down. So the x value is 0, but the y value is -3. So let's use this one. So if I have 0 minus 3, 0, the absolute value of 0 minus 3. So notice this one, the -3, I would have to do inside of the absolute value first. So then it would be 0 minus 3, which would just be -3. So notice the vertex is shifted down on that one. Let's look at this one up here. Now notice this one, the vertex is shifted up. Well, let's try that. If we use 0 on that equation, 0 plus 3, absolute value of 0 plus 3, sorry, you can't see that. 0 plus 3 is 3, so that's why it's 3 units up. Notice in this equation that I have written out here, that's going to be the k value, because that's what's, we'll talk about that. Sorry, that's in the spot of k. So k is going to also do a specific thing. All right, now let's try the numbers being out front, just in this A spot. So let's start with this positive one. So notice if it's in the A spot, the vertex didn't move. It's just that it is now, we call this stretched. I'm going to move this and show you something. So if I think about stretched, so if I'm looking at my V, and if this was my parent function, we call it stretched because I'm stretching it this way. I'm stretching it out. If we think about the other one in a minute that we'll see, is called something else. So a stretch is when that number gets bigger. We're stretching it out like Play-Doh. Okay? So notice the 3 is important because instead of moving up 1 over 1 to that first point right there, it's moving up 3 and over 1. Okay, now let's look at this next one. This one has a -3 in front of the absolute value. So instead of moving up 3 and over 1, it's moving down 3 and over 1. If you think of lines, it would have a negative slope to the right. So it's going down and over. Okay, now the last one I want to look at is a fraction. So if I would do 1 divided by 3, notice that one is wider. So again, this red is still the parent function. And then if you notice, it's going up 1 over 3. So it's switched, kind of like slope, rise over run. It's going up 1 and over 3. Then if we look, so we're going to call this compress. So I think about CPR, like when you're doing compressions on like someone's chest to try to get them to breathe. You're pushing down, so you're doing compressions, and you're making it wider. All right, and so notice that was in the A spot. Okay, so then I'm going to write out that equation, y equals ax minus, that minus is important, h plus k. So the A is going to do something to the graph. The H is going to do something to the graph. And the K is going to do something to the graph. So let's look at it on here, and I have these handy little sliders. So we're going to look at this equation. I'm going to put them back to 0. So notice the A value. Remember, the A value is when the number is in front. So the larger the A value, the skinnier it gets. Notice if I put like 0.5, that would be 1/2, so it's up 1 over 2. If I put -0.5, then it's going down 1 over 2. And then if I put larger numbers, it gets skinnier. So I'm going to put that back to 1. So the A value, we're going to call that the slope. If it's larger than 1, we call it stretch. If it's smaller than 1, it's a compress. So like an example of 0.5, it's compressed. A negative flips or goes down and over. Okay, now let's look at the h. So now if I move the h, and actually I'm going to put this as a positive just for now. In our equation on your paper I want it to be negative, but notice if I move it to a positive 2, it moved the opposite direction of what you think. If I move it to a negative 2, it moved it to a positive 2. That's just like we were doing right here. 3 minus 3 makes it 0. Negative 3 plus 3 makes it 0. So when you go to negative 3, it's actually backwards. So the h, oops, sorry, I dragged it instead of. So h is a horizontal shift, and I want you to write opposite really big. It's the opposite direction of what you think. So if it's negative, it moves right. Positive moves left. Okay, now let's look at the k value. Put that back to 0. K value, remember, if it's positive, it moves up. Negative moves it down. So k is a vertical shift, positive, up, negative, down. So if we do this example, y equals 2 absolute value of x plus 1 minus 3, and I wanted to graph it. This 2 is the a value. It's larger than 1, so it would stretch. The 1 is the h. Since it's a positive, it moves left. And then the 3 is a k. So since it is negative, it would move down. You always have to do this part first. You have to move your vertex and find your vertex before you can do the slope. So I'm going to move left 1. I'm going to move down 3. So 1, 2, 3. So that is my vertex. And then I need to go by my slope, so I'm going to move over 1 and up 2, move over 1 and up 2. And that would be my graph. So that's what the A, the H, and the K, the transformations do.